We're now going to use what we know about similar figures, namely that corresponding side lengths are proportional, to help us find missing side lengths of similar figures. Notice when solving for missing side lengths, you don't actually need to know which one is the new, which one is the original. That is only for finding scale factor. So all we're going to do here is we are going to just label the shapes. We're going to call this A, and we're going to call this B. So we're going to start by setting up a ratio, and we're just going to do A over B. Of course, you can do B over A as well, as long as you stay consistent. Then what you're going to do is you're going to find two side lengths, two corresponding side lengths between the two figures that you know the values of. In this case, it's going to be this side length here and corresponding to this side length here. So all we're going to do is we're going to match this up. So A, right, that side length has a length of 33. B, the corresponding, has a length of 11. To make this a little bit easier for us to work with, let's just simplify this fraction. Alright, so 33 over 11, you know that 11 goes into both of them. 11 goes into 33 3 times, 11 goes into 11 1 time. Now let's set up the next ratio. Let's say that we want to solve and find this missing side length x. Notice that x belongs to figure B, and we need to match this, so B is in the bottom of our ratio, so x goes on the bottom. The corresponding side length to that x is going to be this one here of length 39. That is in A, so it goes to the top of your ratio. All right, and we know that corresponding side lengths are proportional, so what we're going to do is we're going to set these two fractions equal to each other. Now all you're going to do is cross multiply to solve for x. X equals 13, add your units, centimeters. Now let's solve for y. We're going to do the exact same thing. We're going to set up our ratios. So we're going to do the ratio of A to B, and you're going to use the same starting side lengths. So 33 for A over 11 for B. And to make it easier for us, let's just reduce this fraction, 3 over 1. All right. Now we have y, and y belongs to shape A, so that is on the top of our ratio, over the corresponding side length to y is going to be the one with 9 centimeters, so that's going to go on the bottom of our ratio, and since they are proportional, we are going to set them equal to each other. Now again, cross multiply and solve. Seven, add in your units, centimeters. What you might notice at the beginning of this problem is if you take the figure from B to A and the corresponding side lengths from 11 to 33, notice that you multiply by 3. And since they are similar, every side length is going to be multiplied by 3. So if you look at your 9, right, corresponds to the y, I would have to multiply that by 3, and that gives me the 27 that I solved for. And then if you look at your x, right, think about what number multiplied by 3 will get you the 39, and it is 13 times 3, and that's exactly what we got for x. Of course, if you didn't notice this, setting up and solving the proportion is always going to work, and of course, not all problems are going to have numbers that work out this nicely. Let's work through this next example quickly. So first off, label our shapes A and B. And we're going to set up our ratios. And again, I'll just do A over B. And find the side lengths that we know, the corresponding side lengths we know. And that's going to be 4 in A, corresponding to 10 in B. Simplify your fraction. 2 goes into both of them, 2 over 5. All right. Now, let's solve for x. X belongs with B, so that's going to go in the bottom of our ratio. Corresponds to 7, which is A at the top of our ratio. They are proportional, set them equal to each other. Now let's cross multiply and solve. X equal, that is 17.5 millimeters. Now let's solve for y, and we're going to start with the same ratios that we started with x. Y belongs to shape A, so it's going to go in the numerator of our ratio. The corresponding side length to y is going to be 5 millimeters in B, so that goes in your denominator. Set them equal to each other, solve your proportion. So therefore y equals 2 millimeters. Let's look at some applications or real-world problems involving similar figures. You can use similar figures to help you find the lengths, the heights of objects that are beyond your ability to measure. So for example, let's look at this. It says at a certain time of day, a 12-meter flagpole, so this right here, 12 meters, casts an 8-meter shadow. So the shadow of this flagpole right there is going to be 8 meters. If the tree casts a 16-meter shadow, right? So the tree down here casts a 16-meter shadow. Question is, what is the height of the tree? This part right here, height of the tree. And if you notice, if I kind of draw in this line right here, you will see that two triangles are actually formed, and these two triangles are similar to each other. This small one here, and then this overall larger one. So now, because they're similar, let's set up a proportion to solve for the height of the tree, which we'll call h here. And we will just write out the object, so we have the flag, right? And then we're going to set the ratio up with respect to the tree. And we'll start with their shadows first, why not, right? The shadow of the flag is going to be 8 meters. The shadow of the tree is going to be 16 meters. And again, simplify your fraction to make it easier for you to solve. This becomes 1/2. And that is going to equal the next part. The corresponding parts is going to be their actual heights. The height of the flag is 12 meters. The height of the tree, we don't know. Let that be h. Set up your proportion. Now use cross multiplication to solve. And you will get that h, the height of the tree, is going to be 24, and that is meters. You can do a problem of the same type by drawing two separate similar triangles as opposed to one single triangle broken up into two parts. So here in this case we have a problem that says, Old Faithful in Yellowstone National Park shoots water into the air that casts a shadow of 42 feet. A nearby tree is 90 feet, casts a shadow that is 63 feet tall. How high does Old Faithful shoot water into the air? Old Faithful is this geyser. And so again, same thing, these two are similar figures. And so we're just going to set up our proportion. So we have, let's see, the tree, and then Old Faithful here. Okay. And then their corresponding components. So you have their shadows. All right. So the shadow of the tree is 63 feet. The shadow of Old Faithful is 42. Again, simplify your fraction so it's easier to solve. 7 goes into both of these. That would be 9/6. Right? And then now look at their heights. The height of the tree is 90 feet. The height of Old Faithful, we do not know. So set up your proportion, cross multiply, and solve. X equals 60 feet. So the height of Old Faithful is going to be 60 feet. I highly suggest that when you solve these application problems, draw your pictures and label so that makes it easier for you to set up your proportion. There's one more problem on the handout. I want you to solve that last problem on your own to find how tall the actual observation deck of the Empire State Building is. Pause the video. Once you are done, come back and find out the answer. You should get that the observation deck of the Empire State Building is 1,206.82 feet above the ground.